Have the people joined? People. Yeah. Can you see now? Can you see now? Shiny. Shashindra. Yes, okay. Right. So, which part did you miss? I don't know. Did you miss this part? Do I have to explain the whole thing back again? What happens where which part did you miss? You missed the whole thing? My God. You're telling you missed the whole thing? Nice. Beautiful, wonderful. I'm gonna. Right. Guys, listen. So, we were discussing this part, which is the specific heat capacity and heat capacity, right? So, what did I say when we discuss the heat capacity? I'm gonna apply the object the heat, which we call the vastu. Yes? Yeah. So, yeah, I applied the heat to the object. Now, what happens? The temperature increases. When the heat is absorbing, the temperature increases, it rises. So, we discussed that the heat capacity is what? The amount of heat that it takes to increase its temperature by 1 unit, right? So, I am applying the heat to the object and the heat is absorbing by the object and the temperature is increasing. So, the amount of heat that it takes to increase the rise of temperature by 1 unit is that we call the heat capacity, right? So, we turn it into a mathematical formula how the heat capacity is equal to the amount of heat per a unit temperature, right? The amount of heat per unit temperature is the heat capacity. So, we symbolized it, heat capacity, capital C, the amount of heat Q, and the temperature as delta theta, right? So, the units of heat capacity, if I take the Q, the amount of heat, that's joules, delta theta, that is temperature, that is in kelvins. So, joules per Kelvin is the unit, right? That is the unit. And the other thing, we discuss about the specific heat capacity, which is what? We don't take the whole vastu now. What do we take here now? The head. Yeah, you can always go for the head, but that's 1 kilogram, right? Yeah. So that's 1 kilogram. Usually the girls always go to the head, right? Good. So it's 1 kilogram of mass that you have to increase the temperature by giving the heat. So I'm applying the heat continuously until the temperature rise by 1 degree of 1 unit of temperature. So the amount of heat that it takes to increase the temperature by 1 unit of 1 kilogram of mass of the object is the specific heat capacity, right? So the specific heat capacity is the amount of heat per unit mass per unit temperature, which we wrote it as, we symbolize it as simple C equals amount of heat is Q, M is the mass, and the delta theta is the temperature difference. So the units of specific heat capacity is what? Joules per kilogram per Kelvin, right? And we reconstructed the two of the formulas. First thing is this, I isolated the Q value, which is the amount of heat. So I took all the mass and delta theta to the other side, which it made this equation, which is Q equals mc theta, right? Q equals mc theta. So this gives the amount of heat, right? And I reconstructed this equation to Q equals c theta, because I isolated the Q here. So once the Q is isolated, that means Q equals c theta, right? So those are the two of the equations we derived, right? We derived those two of the equations, right? So did you understand now how the physics works? Now this is how actually the physics works. What did you do? We discussed the story, a real scenario that which we call the theory, isn't it? This is the theory. Yes, it's a story, sort of a thing, a scenario that happens. And we converted it into mathematics, a mathematical format, in the divisions, plus and minuses, multiplications, all sort of that, right? We converted it into mathematics. And that mathematical things we converted into a formula, right? Because each and every symbol says a story, says something about it, right? The C says something, Q says something, yes? So all those, we converted this mathematical thing into a formula. And now which do we use now? We use the formulas. But before applying the formulas, there is a whole story that you have to understand. Do you understand that? Now, do you think that just knowing, remembering the formulas can do the application? No. There you have to know the whole thing, the story, right? So deeper you learn, deeper you know about the story, right? So there are small details that you will learn when you go to the university level. In the university level, much of a more real small details will be discussing. Yes, right, guys, did you understand that? People online, Shiny, is this fine now? Did you understand it? Okay, so far okay. I think the OBS recording is there, so if there's any issue, go through the recording back again. I don't know if the අපි discuss කරපු ටික සමහරට black out වෙලා ඇති. Could be. Right, doesn't matter. Right, we'll be discussing the questions and we'll be discussing these things back again and again, so we'll somewhat grab it at some point, so don't worry. Now come to this, amount of heat required, the heat capacity into amount of temperature. So what is the equation here? Q equals C theta. Write it down. Q equals C theta is the equation, right? And define the terms. Q is what? Q is amount of heat. Yes, Q is amount of heat. C, capital C is what? Heat capacity, right? Heat capacity. And delta theta is what? Delta theta is temperature difference. Temperature difference. Yes? Right. So try to understand this part as well. What does it say? The unit of heat capacity is joules per Kelvin, right? That we discussed. So it's joules per Kelvin. When heat quantity is measured in joule and the temperature is in Kelvin, right? That is when you are measuring it in joules and kelvins. Materials of different masses made of the same material have different heat capacity values, right? So when the material changes, what happens? Yeah, the heat capacity changes. So the heat capacity and the specific heat capacity is greatly depending on what? The type of material that you will be using. Yes? Kelvin. Kelvin is the standard unit. Ganna puluwan. I will tell the difference, right? So it's somewhere noted here. I will explain it here, right? So instead of Celsius, instead of Celsius, you can use the Kelvin, right? So now. Oh, now this is the thing. You can apply Celsius or Kelvin. It doesn't matter which unit that you apply it in. The difference will be same. If you applied it in Kelvin and the same values you are applying in the Celsius, it will give the same difference. So if the temperature was given in Celsius, you don't have to convert it into Kelvin because the difference is same. Because if you take the Kelvin value of the two of the different Celsius values and take the difference, it will be the difference of the Celsius values. Same, it will be the same. You know, so you don't have to convert the Celsius into Kelvin to take the temperature difference, because it will be same. This is why. Now, if I take a scale of Celsius, right? So this is a scale of Celsius, right? Because usually the scales are like this, no? So this is a scale of Celsius. I'm starting from 0 Celsius, or much of a, let's say 10 degrees of Celsius. I'm starting from 10 degrees of Celsius and I'm going back, right? And this is 0 degrees of Celsius, right? So divisions are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sort of like divisions are there. And it goes back, like this it goes back. Sort of a large amount goes back, and let's say here is minus 273 Celsius, right? Now the only difference of Kelvin is, the Kelvin starts here at the 0 degrees of, minus 273 degrees of Celsius is equal to 0 Kelvin, right? So 1 Kelvin is what? Minus 72, right? Minus 72, because it's going here forward. Yeah, because it's going forward, right? So 0 is minus 273, 1 is 272, 2 is 271. Likewise, the values are increasing. So the division value, like the value of one division part, is same. So now let's take the difference of, now how much is this now? 0 Celsius in kelvins? 273, because this is 273 of a division. So this is also 273 of a division. So only the difference is the starting and the final values. Here it's 273 Kelvin. So 273 Kelvin is 0 Celsius, and the 0 Kelvin is minus 273 Celsius. But if we take the difference, you are taking the difference of 0, like of 273 Kelvin and 0 Kelvin. What is the difference there? 273 Kelvin and 0 Kelvin. What is the difference there? You deduct 273 from 0. What do you get? I'm going to mash you up. You deduct the 273 from 0. No, I'm sorry, not from 0. You deduct 0 from 273. You deduct 0 from 273. Yeah. Now what is the difference here? 273 and 0. That is 273. Yes, not 0. 273 is the difference, right? So you are converting this 273 into Celsius, which is 0. And you are converting this 0 Kelvin to the Celsius, which is minus 273. Now what is the difference of Celsius? 273. Now do you see the difference is same? Only the starting and final values are different, but the difference is same. So the Celsius difference and the Kelvin difference are same. So it doesn't matter. You apply it in Kelvin, you apply it in Celsius, you get the same difference. So no worries. You can apply it in Kelvin, apply it in Celsius. Nothing changes, right? Understood it? Yeah, sure. Yes? Okay. So now doubts can come when you are applying it to the equations in the questions. Huh? Yeah, tell. Initiation එකයි final value එකයි විතරයි වෙනස් වෙන්නේ. ඒ කියන්නේ අරයා 273 ඉන්නකොට මෙයා 0. So if you are given temperature differences in Celsius or Kelvin, doesn't matter. You take the difference, will give the same difference. The magnitude is same. Starting and the initiation, like this, initiation and the final are only different. Oh, just if you don't understand it, simply whatsoever it is given, get the difference, that's all. Then that is what I said, doesn't matter, you take the difference, right? Right, so the specific heat capacity, amount of heat required to raise the temperature of a unit mass. Now the unit mass is now there of a substance by 1 unit, right, by 1 unit is called specific heat capacity of the substance. So the increasing the temperature by 1 unit of 1 kilogram of a mass, or the 1 unit of mass, is specific heat capacity. So what is the equation here? Q equals mc theta, right? Q equals mc theta. Now define the terms. Q is again the amount of heat and the C is specific heat capacity Ty, and there is C, yeah. And the theta is temperature difference Why are you crying? It's too hard. Then why are you crying? MC theta, the QC theta, and the M is mass, right? M is mass. Understood it? Yes? Yeah? Nice. Right, so can you now, if you understand the specific heat capacity and capacity, can you tell me a relationship between the two of the capacities? Is that, don't tell it now. You already know it, I know. Ah, really? How do you know that? It's also already there. So now tell me a relationship between the specific heat capacity and heat capacity. So what is heat capacity? The amount of heat that it takes to increase the temperature of the whole object by 1 degree of Celsius or 1 degree of Kelvin, doesn't matter. And what is the specific heat capacity? That is not the whole object, only 1 kilogram of it to increase by 1 degree of temperature. So do you see a relationship between there? What? Don't tell, it's beautiful. What do you see the relationship there? Huh? Oh. No. Specific heat capacity එකේ heat capacity එකේ mathematical relationship එකක් තියෙනවා. What is the mathematical relationship there? Now think. Now I want you to think. I don't know. Simple. Okay. Now this is my question. Now think. Specific heat capacity is the amount of heat per mass per degree of Celsius or temperature. Heat capacity is the whole thing, the whole mass per unit temperature. Can you relate them? Yeah. Why? Because ඔයා 1 kilogram වල specific heat capacity එක දන්නවා නම්, and if you know the whole mass of the object, you multiply the specific heat capacity by the whole mass, gives the heat for the whole mass. That means specific heat capacity into the complete mass is equal to the heat capacity, isn't it? Yes, because it's 1 kilogram and you multiply it by the complete mass gives the I try to ඒ කියන්නේ specific heat capacity කියලා කියන්නේ heat capacity එක complete mass එකෙන් divide කරාන් පස්සේ එන amount එක නේ. එහෙම ගන්න පුළුවන් දෙපැත්තෙන් කොහේ හරි. Do you understand it? Good. Right. So it's also given here. What? C equals mc, where C is the heat capacity and the simple C is the specific heat capacity. Right? Right. So these are few of the materials specific heat capacity values, right? Right. Now here, now this says what we discussed. The Kelvin value and the Celsius degree have the same value when considering the magnitude of a temperature unit, right? Because the magnitude of a temperature unit is equal, right? So therefore, in considering temperature ranges, instead of Kelvin values, Celsius value can be taken in the same way, because it will give the same difference, will give the same values, right? Or the temperature එකට ඕන නම් Kelvin දාන්න පුළුවන්, Celsius දාන්න පුළුවන්, Celsius උනත් දාන්න පුළුවන් කියලා තමයි කියන්නේ, right? Then come to the mixture method, right? So we discussed this, right? So what happens in the mixture method? This one, right? We discussed the mixture method. What happens here? You are mixing two objects with, listen, you are mixing two of the objects with two different temperatures, right? Now when you are mixing two of the objects with two different temperatures, what happens there? The one with the high temperature passes the heat. The one with the low temperature absorbs the heat. And what happens to the one with the high temperature when they are passing the heat? The temperature reduces. And what happens to the thing that absorbs the heat? Its temperature will be increasing. And at one point, they will come to a equilibrium. And at the equilibrium, the temperature will be same of two of the objects, right? And we call that temperature the temperature of thermal equilibrium, and it will stay constant there in that temperature if none of the other things are absorbing their heat නේ. වෙන කවුරුද එයාගේ heat එක absorb කරොත් එතකොට එයාගේ heat එකත් අඩු වෙනවා. If none of the things are absorbing their heat, the temperature will remain at that level, right? Right. So now we will have to apply this into a formula, mathematical thing. So what is the mathematical formula we are going to apply here? Now this is the mathematical formula we are going to apply. So the heat, first formula is heat released, right? Heat released or passed by the metal, right? By the metal is equal to what? Heat absorbed by what? Here it's water. The heat released by the metal should be equal to the heat absorbed by the water. And that heat, we measure it using which equation? mc theta, right? Because Q is the amount of heat, right? So Q equals mc theta. So amount of heat which the metal passes is equal to mc theta, right? It's mc theta of the metal. So here the we'll take the m as mm, right? I'll take the m as mm, right? I'll take the m as mm, the mass of metal, right? Listen. Before you're writing, listen. The mass of metal is mm, and the specific heat capacity of metal is cm. Now, what is the temperature difference that occurred when they are passing the heat? The temperature difference that occurred when they are passing the heat is the 90 to, you don't know it now, 90 to theta, you don't know the theta, but 90 to theta is the temperature difference. Hi. Oh, him bad. You can theta එක හොයන්න, you can add the 90 and 30 values together and you can divide it by 2 to get the theta value. It's a different case because it depends on the capacities. ඒ හින්දා අපිට කෙලින්ම එහෙම divide කරලා ගන්න බෑ. equal amounts වලින් යන්නේ. දෙකට බෙදලා යන්නේ. Different values වලින් යන්නේ. So the temperature difference here will be 90 minus theta, right? It will be 90 minus theta, right? Equals heat absorbed by the water is mW, which is the mass of water, and the Cw, which is the specific capacity of water. And what is the temperature difference that happens when they are absorbing the heat? Yeah, the 30 increased up to theta. Now the temperature difference is high to low, which is theta minus 30. So that will be theta minus 30 degrees of Celsius, right? So this equation you have to apply, right? And now here we consider that the container doesn't absorb any of the heat, right? Because the heat released by the metal has only absorbed by the water. Now what if the container is also absorbing the heat? What if the container is also absorbing the heat? Like in the previous one. Exactly. මොකද්ද? නෑ අපි ෆෝමියුලා එක ගන්න කොහොමද? මෙයා what is this? මෙයා heat එක දෙනවා. මෙයා 100 joules දෙනවා. මෙයා 80 joules ගන්නවා. මෙයා 20 joules ගන්නවා. එතකොට metal එක heat එක පිට කරනවා. Who takes the heat now? Water and the container. N is what? N is a plus. N is a plus, right? That is how the language turns to the maths. N is a plus, right? Water and container. Hey, IT, this is not IT, this is physics, right? So it means this, right? So it means you have to add the basin as well, or the container as well. So if I write the second equation using that, it will be heat released by the metal is now equal to heat absorbed by water plus what? Heat exactly absorbed by container, isn't it? Yes. So it's metal MC theta, water MC theta plus containers MC theta. Yes. Follow. C theta උනත් දැන් C theta C value නම් දීලා තියෙන C theta දාන්න පුළුවන්. mass දීලා නැත්තම්. Because the heat release is equal to the heat absorbed by two of this. So the heat එක අපි measure කරන්නේ MC theta හරි C theta වලින්. ඉතින් either C theta or MC theta we can apply. Yes. Do you understand that part? Yes, nice. So come to this part. Now write down the whole thing here in the books. Now guys, have you received this tube? Shiny? I don't think. No, I printed this today. Right? Write down this in the box. In the box, write down this part. Oh, it's a complete thing. Right.
ජීවිතේ අමාරුයිද?
Finish? Finish? Guys, finish? Did you take a note of this? Right. So if you finish, come to the exercise 1 and voila, do the questions. Come on, man. We have like 15 minutes of atonement because we started a bit late. Do the questions. Did you understand the theory up to now? The whole thing? Yes? Anybody found the answer for the first question? කීයද? කීවෙනි answer එකද? Second answer 9,000. Get the same. What did you get? What did you get? What do you have to apply there? What is the MC theta? Q equals MC theta. But you had to come with exact answer like 9,000 අතනව තියෙනවා. So if you so which is the correct answer, 9,000 or the 90,000? Shiny, what is the answer? Shashinder, for the first question. Something is happening to the display. Maybe my I fixed the display, is it? No, right? Guys, what is the first answer? Hmm. 90,000 then? What about the second? 60, no, 630,000. Okay. එහෙම කන්නේ. එහෙම නෑ. එහෙම හිතන්න එපා. Third answer. Is it for the first question or the second question? Third answer? Second question, third answer. Now tell me the exact correct answer that you got. Now what the hell, bro? You can't answer the exams like that. 63 ඉස්සරහ එකක් කියලා එනං paper එක බලන මනුස්සයට කියන්නේ. Now use it now. Find the correct answer. Be I think me have a calculator, not a mobile calculator. Have confirmed answers or me වැටවුඩ answers වල ඉන්න එපා නිකන් ඒකත් වෙන්න පුළුවන් මේකත් වෙන්න පුළුවන් ඒකද දන්නේ මේකද දන්නේ එහෙම බෑ. First answer for the second question? No, he says the second as well. Shashinder. Shiny got the same answers, yes? No. Second question, first answer. Yeah, same. Third question. So I'm going to scroll up a bit. What is the answer for the third question now? Water. 4200 is water. Oh. පොඩි වෙලාවද? Finish. right? Yeah. So shall we check the first question? Find the amount of heat required to raise the temperature of 5 kilogram mass of aluminium from 40 degrees to 60 degrees. The specific heat capacity of aluminium is 900, so it's mc theta, right? I'm going to write it here. Q equals mc theta, right? So m is 5 kilograms, yes, and the C is 900. So I'm going to take just the values instead of the units. Okay, right. So it'll be 5 into 900 into the temperature difference is 60 minus 40. So it's 20, isn't it? Yeah. So that will be 45. 45 into 2 is 90,000, right? Yeah, that is the fourth answer, isn't it? Third. What is the answer? Third answer. Same. Third question. Okay. Second question. How much heat is required to raise the temperature of 3 kg of water by 50 Kelvin? The specific heat capacity of water is 4200. So it's again the Q equals mc theta you have to put. So the mass is 3 kg. The specific heat capacity is 4200 and the temperature difference is 50. So 50 into 3 into 42, that is how much? Third answer is it? 63,000, right? No. First answer, this much. Right. So this one, a metal container with a specific heat capacity of 800 kilogram per Kelvin contains 0.5 kilogram of water with a specific heat capacity of 4200 per kilogram per Kelvin. The initial temperature of the system is 30 degrees of Celsius and the mass of the container is 0.2 kilogram. Find the amount of heat required to heat the system, right? So the heat is equal to the amount of heat that it takes by the container plus the amount of heat that it takes by the water, isn't it? So the addition of two of the mc thetas, isn't it? So the complete Q, shall I do it somewhere it's more space, right? So the complete Q is equal to the mc theta of water, or the heat absorbed by the water and the heat absorbed by the container. So mc theta for the, I'm going to put the mc theta for the, shall I write it this way? mc m1 c1 theta plus theta 1 plus m2 c2 theta 2, which are the heat absorbed by the water and the container. So I'm going to apply it down here. Right, I'm going to apply it down here. So the Q equals mass of water 0.5, right? 0.55 into specific heat capacity is 4200 and its temperature difference is 30 to 60, right? So 60 minus 30, always deduct the greater amount from the lower amount, plus you have to add the mc theta of the container as well. Now the container is 0.2 kilograms and the specific heat capacity is how much? 800 and the temperature difference is same, right? 60 minus 30, right? 60 minus 30. So simplify the two of the values. Now this is 30, so 30 into 0.5 will be 15, 15 into 4200, how much is it? 66,000? 63,000, okay. Now this is 63,000 plus, how much is this? 20 4,000 4,800, is it correct? 20 into 2 is 2. Is this correct though? Now this is 20. 20 into 2 will be 4. 4 into 8 will be? I'm sorry, 30, right? Yeah, now it's correct. 6 into 8 will be 48,000. Yes. So adding together, how much is the value? 67,800. The answer is third part. Yes? Nice. Is it a metal container with specific heat capacity of 800 kilogram per Kelvin? Now that is the specific heat capacity of the container. Just take the details separately. And contains 0.5 kilogram of water with a heat capacity of 4,200. Now the weight of the boat is 0.5, specific heat capacity is 4,200. The initial temperature of the system is 30 and the mass of container is 0.2. It's really clear for myself, I don't know. Find the amount of heat required to heat the system to 60. Because you haven't practiced it. Oh, itutti gedadi hadanna bit of a මේකයි චුට්ටක් try කරන්න හොඳේ. You do it at home, try it at home. So we'll be doing a new part the next week, right? So guys online, adios, see you, catch you. Tell somebody to come. I don't see Malchi. No. Can you tell somebody to come? Switch off the recordings.